Okay, now atmospheric pressure and absolute pressure. Atmospheric pressure is force per unit area exerted against a surface by a weight of the air above that of the air atmosphere. Now, atmospheric pressure um, is closely approximated by the hydrostatic pressure caused by the weight of the air above the measuring point. Now, if there are low pressure areas that have uh, low pressure than the atmospheric, and if it's high pressure areas that have the more atmospheric mass above their location. If you increase the elevation, if you go up high, there is less atmosphere, and if there is less atmosphere there is less particles there. If there are less particles there, the air is light and thin, which means there is less mass acting downward. There is less mass weight of the air acting downward, hence the pressure is going to be less. Then we use a standard pressure. The standard atmospheric pressure, it's 101.325 kilopascal or 101.325. That's the value we actually use. These values are same as amount of the mercury displaced, which is 760 millimeter of the mercury that's been displaced. How they find this one out? Um, if they got the way they do this experiment is, if they got a tray filled with mercury and they put a tube, a tiny tube here, and they fill this one with mercury, because mercury has its own weight. The mercury will rise in the tube to a height of 760 millimeter. If it's a water, it's going to rise more. Why? Because the atmosphere, which is here, is exerting pressure on this fluid. Hence, the fluid has to go that way. The heavier the fluid, the less it will rise. The lighter the fluid, the more it will rise. Yeah. Okay. Okay. Now, this is also known as, we use sometime bar, which is 10 to the 5 Pascal, which is another unit we actually use. So we'll discuss that one later. Now, then there is gauge pressure and absolute pressure. Now, the gauge pressure is measured relative to the atmosphere, whereas the absolute pressure is measured to the perfect vacuum. Right now, for example, we said if we got a gauge here, the gauge is going to show you the reading 0. But there is atmosphere pressure. So on our skin, there is a pressure of 101.325 kilopascal. That's the pressure that air is exerting on our skin. If we don't have our pressure, what will happen? So we will see our veins quite obvious. This is why when you go to high altitude, you are able to see your vein, the blood rush towards your skin. So you see more red skin there. Now, let's say I will show you the picture figure next here. Let's say we got P1, P2, and we got the at the ground here as well. Now, at this level here, this is the surface level, the zero gauge pressure. There is a pressure here is zero gauge pressure. If you move down here, there is a negative pressure. Yeah. If you move up, obviously it's going to be more pressure, or sorry, less pressure there. Now, let's say we are looking at the relative pressure to the volume. Let's say pressure 1, that's with a vacuum, sorry. Pressure 1 is 0.7 bar, which is absolute. It's an absolute pressure. Yeah, from here to from the vacuum, this is a vacuum. So that's, let's say, 0.7 bar. and then we got 3 gauge pressure, so that's going to give you the final pressure. P2 is like says 2 bar absolute. This is a pressure greater than the atmospheric pressure. So if you're looking at P1, that's going to be 1 minus or 0.7 minus 0.7 minus 1, which is going to give you negative 0.3. So that means there will be a suction. Okay. Now the formula is absolute pressure is equal to gauge pressure plus the atmospheric pressure. Now these always suction will exist in certain location of the fluid power. If the pressure is below the atmospheric pressure, the suction will occur. If it's more than that one, then it's mean the pressure will travel from a high towards a low. Now let's say we got a control valve here, and we want to actually lift the load which is on this side. The piston has a diameter, so that piston has a diameter of 250 millimeter. Now this thing is exerting a force, a downward acting force of 13300 Newton, and I want to lift that one. How much oil pressure is required to lift this bit? So I need to find the pressure of the oil. To do this one, I got the value of the force acting downward, which is 13300 Newton. I have the diameter. So the first thing we do is convert the diameter into meters, and then also in radius, because radius formula is much easier. So once you got the value, convert this dia into the radius. So the radius is half of the dia, so it's going to be 0.125 meters. Once you got that one, you have an equation, pi r square. Put this one in this equation, put the values, pi r square, and then you need to divide this by then you need to put the force, which is 13300, divide pi r square. R is 0.125. Make sure you put the square here, and that will give you the value for the pressure. Now the value for the pressure will be in Pascal. Once you got the answer in Pascal, you need to convert that into kilopascal. So whatever answer we got, because we need in kilopascal, so you need to divide that by 1000, 270.945. So I divided that by 1000 and we got an answer in kilopascal. Let's say we got a power lift, fluid power automobile lift system in this figure 1.5. The air pressure is 550 kilopascal of a gauge pressure. If the hydraulic piston has a diameter of 250, so we're looking at that piston here. That piston has a diameter of 250 millimeter. What is the maximum weight of an car that can be lifted? So we're looking for maximum weight. The specific gravity of the oil is 0.9. So specific gravity of the oil is 0.9. If you want to find the density, multiply that by 1000. So that will be 1000 kilogram per meter cube. What percentage error in the answer to the problem occurs by ignoring the 1 meter head of the oil? Because again, there is a 1 meter head of the oil from this surface, this layer of the oil to that layer of the oil. There will be some other pressure, this pressure, hydrostatic pressure of the oil, which is acting downward, we need to overcome that. So what is a percentage error which results in the calculation because of that oil? So this is 1 meter. Specific gravity is 0.9. The diameter here of the piston is 250 millimeter. So we need to do our calculations now. Now, first thing is we got the pressure of the air as 550 kilopascal, which is given here, 550 kilopascal. We need to find out the pressure of the air. Pressure of the air is same as pressure of the piston plus pressure of the oil. Now pressure of the air is 550 kilo, so I convert that one here. Now let me just correct that one. Let's put it right. So that's the pressure of the piston. So let's put piston. Yeah. So that's the pressure of the piston, and pressure of the oil is rho gh, the density, the gravity, the height. And I want to find out the pressure of the piston. So this rho gh is being multiplied here, and I'm looking to find the pressure of the piston. So I need to move this thing on the other side. When I move this thing on the other side, it will be a negative. That will become a negative. So 550 times 10 to the 3 minus the rho gh, and this is pressure of the piston. Yeah. And then I put the value. We have the density of that one, the rho value 550, I copy it here, minus there. This value is 900, doesn't matter any order, so that's 900, times by g, which is here, times by the height, which is here. So rho gh, if I rewrite that one much better actually. And then we will get an answer. So if we put in calculator, and we will get an answer of 550 times 900 times 9.81. So we will get an answer of 541.171. This is also in kilopascal. Yeah, I converted that in kilopascal straight away. Yeah, whatever answer you get, divided by 1000 in kilopascal. Now, this answer, you just also put that one here to find the percentage error. But when you put that one, make sure the percentage error is with relevant to the pressure of this piston. So that has to be in the denominator. And when you put that one, that will be 0.016. But make sure you multiply by 100 to convert into percentage. So multiply by 100, and that will be 1.63%. That is going to be the percentage error.